Hi there, it's time to practice everything we've learned about multiplying binomial expressions together. So you've got 8 different examples here. Try and multiply them together and simplify, see what you get. Pause the video here, and then we'll come back and do them together. All right, so let's try the first one. What do we have here? We have x plus 2y multiplied by 2x minus 3y. So we're just going to FOIL these two binomials together. Okay, so remember when we FOIL, we're going to multiply the first times the first, the outer times the outer, the inner times the inner, and then the last times the last. So first times first, well, that's going to give us x times 2x. Outer times the outer, that will give us x times negative 3y. Inner times the inner will be 2y times 2x. And finally, last times last will be 2y times negative 3y. Okay, so now we just have to simplify from here. X times 2x, that's 2x squared. Well, actually, here we'll get a minus 3xy. Here we will get a plus 4xy, and the last term will give us a, well, I guess it'll be a negative 6y squared. And so then we can actually combine these two like terms to give us 2x squared plus xy minus 6y squared, and that should be our final answer. Okay, let's go to the next one. This next one is another set of just two binomials that we're multiplying together. This one's an x squared, but that doesn't really matter. We can still FOIL this, okay? So let's do that. We're going to FOIL these two together. So first times first will be 7x multiplied by 2x squared, right? Outer times outer, that will be 7x multiplied by negative 1. Inner times inner, that's negative 5 times 2x squared. And finally, last times last, it'll be negative 5 times negative 1. Okay, so this is how we can FOIL it. Now we just need to simplify. So simplifying here, we're going to get 7 times 2 is 14x cubed. Well, we get a negative 7x here. Here we'll get a negative 10x squared, and finally negative 5 times negative 1 will be a positive 5. And let's just write this down in standard form. So we want to start with the highest power and then sort of go down from there, right? So this will be the same as 14x cubed minus 10x squared minus 7x plus 5. There we go. Okay, that'll be our final answer for that one. Look at the next one. Okay, so this one we could FOIL, right? That's always a valid option, but recognize that this is actually one of those special product rules that we learned about. This is the sum multiplied by the difference of the same terms. Okay, so let's remember what this rule looked like. It's saying if you have some a plus b multiplied by a minus b, this is actually going to be equal to a squared minus b squared, right? So that's what this is going to be. So let's use that special product rule here. We're going to get a is square root of x, so that'll be squared, minus b is 4 squared. Okay, so if we do that, we're just going to get x minus 16. So that simplifies down quite nicely. Let's look at the next one. Here again, we could FOIL, right? You could consider this as a 4x plus 3y multiplied by itself, and you could FOIL that. But we don't want to do that. Instead, we're going to recognize that this is the square of a sum, right? That's what this is. You've got a sum squared. So the rule here was going to be if you have some a plus b squared, this is actually going to be a squared plus 2ab plus b squared. Okay, so this is a very, very common type of procedure we're going to be using here. So remember this 1, 2, 1 coefficient pattern. That should serve you well. So let's do it that way. In that case, we're going to have a squared. Well, that's 4x squared plus 2 times AB. Well, A is 4x and B is 3y. And then we're going to add B squared, which that's 3y squared, right? That's implementing the rule here. And now let's simplify. So 4x quantity squared is going to be 16x squared. Here we'll have, well, 2 times 4 is 8. 8 times 3 is 24. So this will be a plus 24xy. And finally, 3y quantity squared will give us 9y squared. And that should be our final answer right there. Okay, let's take a look at the next one. Okay, so here, again, we could FOIL if we wanted to, but better to recognize this is the square of a difference. Okay, square of a difference is going to be very similar to what we looked at just now. This is some a minus b quantity squared, and that would give us a squared minus 2ab plus b squared. Okay, so it's the same 1, 2, 1 coefficient pattern, but we have a negative sign here, and that's because we're treating this as sort of a negative b, right? And so when it's to an odd power, it's still going to have that negative sign out there. Okay, so let's do this one. We'll have an a squared, so the a is 2x quantity squared, minus 2 times a is 2x, b is going to be the square root of 3. And then finally, we're going to add the square root of 3 squared. Okay, so let's simplify this now. This is going to give us 4x squared. And then here we'll just get a minus 4 rad 3 times x. Can't really simplify that any further. And finally, the square root of 3 squared, well, that's just 3, isn't it? Okay, so here we are. Final answer. Let's look at the next one. Okay, so this one, well, it's raised to a power of 3. Okay, so we want to recognize this is the cube of a sum. So let's see if we can remember that rule here. If we have some a plus b cubed, what do we get? Well, we're going to get this 1, 3, 3, 1 coefficient pattern. Okay, so that's the coefficient pattern, and it's going to start with a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay, so we've got this 1, 3, 3, 1 coefficient pattern. And then the powers of a start from 3 and then they go down to 2, to 1, and then to 0. And then the b's go up. Here we have b to the 0, b to the 1, to the 2, to the 3. They go up. Okay, so this is the pattern for the cube of a sum. So let's just follow that pattern then. So we're going to start with 2x quantity cubed plus 3 times a, in this case is 2x, b is 3y, and this a is going to be squared, plus 3 times, same thing, 2x, but this time to the first power, and this time this 3y is going to be squared, and then finally we're going to have b, which is 3y all cubed. Okay, so that's sort of a shortcut we can use because of that rule, but we still have to simplify. Okay, so let's simplify. 2x quantity cubed, that's going to be 8x cubed. Here, what are we going to get? Well, okay, let me simplify this in a few steps. So we'll have 3 times 3y, that's going to be a 9y, multiplied by this 2x quantity squared, that's going to be a 4x squared. Okay, over here we're going to get 3 times 2x, that's a 6x, and then we have a 3y quantity squared, that'll be a 9y squared, and then here we're going to have a 3 cubed. Okay, 3 cubed is actually 27y cubed. Okay, so we're almost done, just a little final simplification. This will give us 8x cubed. Plus 9 times 4 is 36, so 36x squared y, plus 9 times 6, that's going to give us a 54xy squared, plus 27y cubed, and I think we've finally done it. That should be our final answer there. Hopefully you got the same thing. And let's look at another one. Okay, so here now we have a difference. Okay, a cube of a difference is what we have here. So this is going to be a very similar rule to what we just had. In fact, let me copy the rule we just had. So this is the rule here. And let's erase that. Okay, so this is the rule for the sum. Okay, now if we want to make this into a difference, what do? Well, this is going to be a difference. We have to alternate our positive and negative signs. So this one will still be positive, but this one will be negative, this one will be positive, and this one will be negative. Okay, I'm going to write that down. Okay, so this is going to be the rule when we have a cube of a difference. And the reason why is because we're sort of having this negative sign with the b, so whenever b is raised to an odd power, like here, b to the first power or b to the third power, that's an odd power, the negative sign will stay. But if we raise it to an even power, well, then you have a negative times negative, the negative sign disappears. That's why we still have a positive sign here. Okay, so that's where this rule comes from. Let's now implement it. So a is 1, so we're going to start with 1 cubed. That's nice, okay? And then we're going to get a minus 3 times 1 squared times a b, which is going to be our 3x squared to the first power, right? Next, we're going to have 3 times a, which is just a 1. And then we're going to have this 3x squared quantity squared. And finally, we'll have minus this 3x squared raised to the third power, just like that. Okay, so now let's simplify. Well, this is just 1. Okay, that's nice. Here we'll have a minus 3 times 1 times 3 is 9x squared. Okay, that works out. Here we're going to have a plus 3 times 1 times, well, okay, so let's do this one first. This is going to be a 9. So it's 3 times 9x to the fourth power. And then finally here we'll have a minus 3 cubed is 27, x squared cubed is going to be x to the sixth power. Okay, so let's just simplify this. 3 times 9, well, that's going to be 27. And so this is our final answer, but I want to write it in standard form. So we're going to start with the largest power here. So this will be a negative 27 x to the sixth power plus 27 x to the fourth power minus 9x squared plus 1. And now this should actually be our final answer here. Okay, let's do one more. This is the last one, and this one can look a little bit difficult. If you decide to do this square of a sum first and then do this square of a difference, and you're going to get a trinomial here and another trinomial here. So you're going to have some kind of a plus b plus c multiplied by some d plus e plus f, and that's messy, okay? Multiplying two trinomials together, that can be a lot of terms. So instead, what we're going to do is we're going to recognize that I can write this as essentially 2 root 2 plus x multiplied by 2 root 2 minus x, and then I'm going to square all of this. Okay, so essentially I'm taking this square and I'm sort of factoring it out, right? And we can do that because of how exponent rules work. A power sort of distributes over multiplication, right? So you could distribute this in like that. Okay, so if we rewrite our expression like this, then normally we could sort of see what we're doing inside here, and this is actually going to be the product of a sum and difference of the same terms, right? This is what we were looking at for one of our earlier problems. This is actually some a plus b times an a minus b, and we know this is going to equal a squared minus b squared. Okay, so we can use this. So what do we have here? Well, this is going to then simplify down to, well, a is 2 root 2. We're going to square that, and then we're going to subtract b squared, just like that. Okay, so we're going to get this, but of course everything is still squared. Okay, so let's simplify this. The next step here, we're going to see this is 4 times 2 is going to be 8 minus x squared, quantity squared. And so now what we have is the square of a difference. Okay, and the square of a difference, we should remember our rule. A minus b squared will be a squared minus 2ab plus b squared. Okay, so now we have to implement that rule here. So what we're going to get here is we will get 8 squared. We get a minus 2 times 8 times x squared plus x squared squared. Okay, and so let's compute what we get here. Let's do this first term. X squared squared is going to be x to the 4th power. Then we're going to have a minus 16x squared and a plus 64. Now this should be the final answer over there. Okay, so hopefully this was some good practice using our binomial product rules and just multiplying binomials together in general. All right, come back next time. We're going to start factoring. I'll see you there.